You're listening to the Turing Podcast, a production of the Alan Turing Institute, the UK's National Institute for Data Science and Artificial Intelligence.
Hello everyone and welcome to another episode of the Turing Podcast. I'm Ed Calstri and I'm here with B. Costa Gomez. B, how are you?
Hi, I'm doing fine. How are you?
Not bad. We should be releasing this episode on September 16th, which is International Identity Day. What's your identity, B?
I was gonna say this is I am going through as any writing up PhD student an identity crisis right now.
Right.
So I'm the wrong person for you to ask what's my identity currently.
I couldn't think of another appropriate question to ask with regards to identity. But yeah, as our listeners will hear, we've got a project at the Institute related to digital identity, and we've got a professor who's a fellow at the Institute to talk about that. But I'll just give a little bit of a summary of the topic first, because I think this needs a little introduction. So identification, it's something that's come a long way since the 1990s, when paper-based registries and documents like hardcopy passports were the only option for fully verifying your identity. Nowadays, there's a proliferation of digital identity systems. These are both national systems and commercial ones. And you can identify yourself, and those things, you can verify your identity, importantly, and that can be checked securely, cheaply, and at scale, which is obviously very different to the previous paper-based systems. But whether those digital identity systems will achieve fair and just outcomes remains an open question. If societies want to use them to empower citizens, then identity systems need to be properly designed and deployed. And those considerations haven't necessarily been a priority in the development of all of the digital identity systems so far, as we'll hear from Professor Carsten Maple, who we're interviewing today. But it was an interesting chat. What did you think, B? It was good, wasn't it?
I really enjoyed it. And there's a lot of considerations, as you said, that are being thought of now, but not necessarily have been the priority before. And I think I also like the political correctness with which the questions are answered.
When you get to the end of the episode and you come to the bonus question, you'll hear what B's talking about there.
Because when we think about identity and protection of identity, we instantly think about cases where we know that this isn't happening. So it was quite good to hear what are about the project and how things are going.
It's a topic of interest to anyone who cares about things like human rights or reducing poverty and these kinds of things, sustainable development goals. On with the interview. Hello everyone, today we're joined by Carsten Maple, who is a professor at the University of Warwick and a fellow of the Alan Turing Institute. We're going to be talking to Carsten today about one of the Alan Turing Institute's major new projects on trusted digital infrastructure for identity systems. Carsten, welcome to the podcast.
Hi Ed, good to see you all.
Welcome, and we'll talk a bit later on about the work that is going on at the Institute. But first, Carsten, what is actually a national digital ID, and how does it differ from the kinds of ID we're more familiar with in the UK, like driver's license or passports?
Oh, so thanks, B. Well, one of the things to think about is you mentioned some of the kind of identity systems we have in the UK. So driving license being a good example and the most common example. If you want to go and buy glue or cigarettes or all sorts of things now, scissors or even a knife, I think, right? You're asked about your age. Yeah. And one way that you do that is you say, yes, I'm of the right age because here's my driving license. Driving license is what we call a functional identity. Really, it's an identity that we use to say we are qualified for driving, or we have a provisional license. So in that sense, it's a functional identity. But in the UK, we tend to use that as a more foundational identity. We use it for more things than it's really designed for. So within national identity systems, what we typically talk about is a foundational identity system. And that's basically an identity system that recognizes just who you are. Yeah. So it ties a person to an identity, often to something called a UIN, a unique identity number. And that foundational identity can then be used to build upon, to build from it some functional identities. Yeah. So a functional identity might be a driving license, but it could be lots of other things as well.
Passports or something like that.
Yeah, indeed. So in the UK, we don't have a digitally identity system. And in fact, there's been some talk this week about introducing that. Again, we've tried twice to have a digital identity system, and each time it's been kicked into the long grass for various reasons. I did hear somebody saying that it's equivalent. We're equivalent with identity to the Americans with gun law. We resist it at all costs, but it'll be interesting to see if we have one. So what we typically do is think about these national identity systems as foundational, and then, as I said, there's these functional. And the reason for that, if you don't mind me telling you a little, is because remember that example that I said about where you use your driving license?
Mm-hmm. Yeah.
Think of all that information that's on your driving license. Yeah. Why do I need that so I can buy a knife or it's got my address on it. It doesn't just say the age, right? It says what my date of birth is. So we should really be using identities as in the right way, and that's why it's good to have this foundational identity, and then you can have very specific functional identities. And one would be just this thing that we've tried before, these age proof of age cards. Goodness me, there was one of those when I was about 18. I don't know if that's still going or how successful those kind of things are, but they come in waves, and that's the reason we try and have a national digital, because of what we're doing at the minute. We do a lot of things online, identity system.
Cool. And I think your explanation of the UK's scepticism around these all-encompassing foundational ID systems leads really nicely into the next question, which is, well, like what are the main problems that digital ID systems intend to solve? Why are the international development community so keen on their adoption? So,
national identity systems can offer a lot of benefit, and they're used in different ways. So there's a different sort of motivation in the UK to elsewhere. So I think it's important to state that first. So people will do it for all kinds of reasons, and it could be to argue for national security, to know who's doing what. It could be for a number of other reasons, and digital, as I said, because we're doing a lot online. But the international development community are particularly interested. And why is that? Well, they are interested in humanitarian purposes, right? So, for example, the program that we've got at the Turing Institute is funded heavily by the Bill and Melinda Gates Foundation. And the Bill and Melinda Gates Foundation sees that it's really important to have access to finance, for example, to get out of poverty. And one can see why that is, right? If we agree that if we can give some support, rather than just necessarily giving aid, but we give some support financially to help people have better lives and create businesses or whatever they want to do by things that are ultimately more efficient, then they need access to finance. But you can't borrow money if you don't have some identity, because no one will lend it you. And in fact, these humanitarian international development agencies cannot give money without that kind of identity. You'll know that even in the UK, right, a good example of identity is around financial things here. You know that you know to go to a bank, you've got to prove who you are, and that's to stop all kinds of fraud. Well, think about that in the international development communities, right? If you want to give and it even is true of food and other aid. If you want to give that away, there's the potential for corruption, right? And that people could abuse that system. So if there was no check on identity, what you might get is that people would be able to claim that there was a lot of need and a lot of delivery of funds or of aid, which cannot be verified. So that's why the international development organisations want to do that, because it stops that kind of leakage. At the moment, they are carrying a risk, because what they will do at the moment is that they'll give aid, because they have to balance things up, right? What do? Am I really certain that you are the person who needs that resource or do I just not do it? Well, that's about a risk kind of thing. They won't risk at the minute not giving a person because there isn't an ID, but that if they had one, they would make sure it was more importantly going to the right people.
Okay, which it's a perspective and goes nicely into my question, because what about the other way around? What is it all also about preventing? We're talking about fraud from the person, someone saying that they are not who they say they are, they no need. But is it possible about that this project at the Turing helps preventing governments from using digital ID to discriminate against people?
Yeah, you're mentioning something that's really important there, B. What's really important is if you've got these identity systems, they've got to be trustworthy. Yeah. Ed mentioned about the skepticism in the UK. Yeah. Well, that's not skeptics from the government necessarily worried about fraud. That's about people thinking, I don't want to be tracked. I don't, surveillance capitalism, a term that's been pretty big in the last couple of years. Yeah.
Or just a good old-fashioned government surveillance, I guess.
Yeah, indeed, right? So people are concerned about the Big Brother aspect, the controlling nature. That you'll have seen a lot of that in, online circles recently. There are big communities that are talking about this and are concerned about this. Whether it's justified or not, that's another matter, but it's their perception. So trustworthiness is really important. And what you've highlighted there, B, is something that, who are these, let's call them bad actors in this system? Now then, one could argue whether somebody in the UK trusts the government. I would argue that we should, in a sense, because we are democratically elected, and there's some governance, and there's some questions about that, especially around COVID-19 at the minute. People saying that things are coming into law quite quick, and there's a lot of powers, but we have a democratic parliament, that there are ways that can be managed. But in other countries, that's not necessarily the case, right? There are many countries where there isn't democracy. There's a dictatorship. There's countries where, let's call it contested government, right? There are countries that may not even have a properly formed government because there may be some military control. In all of those kind of situations, if you've got this kind of identity system, wow, isn't that powerful way in which, especially with data science, right? We're all at the Alan Turing Institute. Look at what you can infer about data. So not even data that's held in that identity system, but what can be inferred. And all of a sudden it's very rich, and in the wrong hands, that's bad. So trustworthiness is absolutely vital. And it's vital that we protect it against those criminal gangs, in those regions that I mentioned, in developing nations. You want to protect against some kind of regional or local kind of, let's call it mafia type thing, but it's just some bad actors in that space, right? So that bad individual, the bully in the town or whatever, and you've got to protect against people who are malicious, claiming falsely things. So just individuals. So there's a whole range of actors we have to think about, including governments, and we have to try and have this trust in this system if it's going to be fair and ethical.
Because it can be misperceived from from the government down or from the person up as well. So yeah.
Indeed.
Right, yeah. Lots of things to consider there from the point of view of trustworthiness with these systems. So I'm going to ask you a slightly more specific question now. So there's a variety of what could be described as open initiatives currently underway in the research space around digital identity. One such project is MOSIP, which is an open source identity platform being developed out of the International Institute of Information Technology, Bangalore in India, which the Turing project is collaborating with. Can you tell us a bit about what we're talking about when we say open in the context of research software, and specifically how this plays into digital ID projects like MOSIP?
Yeah. So I think, Ed, you know a bit about openness, and many of your colleagues will as well. So
I should say at this point in the podcast that I'm actually personally working with Carsten on this. So I've asked him a pretty specific question there, to which I know some of the answers, but I'm interested
exactly.
to see what he says.
Indeed, and I think, as we discuss in some of the work that we're doing, openness is a real question about what do we mean by open. So first of all, with openness, there is a principle, a reason why we're doing openness. Okay. So openness is designed for many different reasons. And if we think about sort of operating systems, of course, we've got the more closed source, the iOS, for example. We've got more open source, which might be sort of your Android kind of approach, right? And Linux approaches. And the idea has been, in some of this idea of openness, is to encourage innovation, right? It's really to encourage collaboration and participation. And sometimes it's seen that openness is in conflict with commercial interests. And sometimes that may be true, but it doesn't have to be. So if we think about Linux, Red Hat was a big organization, right? And Sun has been involved in some closed and open source developments as well. So the thing is, with openness, we've got this idea of trying to get some collaboration and also some community. So almost crowdsourcing effort, but also that helps in crowdsourcing people who are going to challenge the system and try and break it. So from a security perspective that I'm from, it's quite interesting because we used to do security by obscurity. Don't tell anyone. Yeah, we know lots of things and the bad guys won't know, so they won't be able to break into it. Well, of course, that isn't as true these days because the bad people are pretty smart. But also, with the way that information is conveyed at the minute, you just can't control that information, so it gets out. Yeah, so you can't do security by obscurity anymore, so we tend to be open. And this is why we develop standards and open standards and open source software. One reason is so that then you can say, right, this is open, try to attack it, you can understand how it works and people can improve it, and it helps that security. So openness depends about how much you're doing it. I mentioned open standards and open source. Open source, you all of the code is there. It's on a code base, typically on GitHub or something like that. Yeah, but that code base is released and people can improve it. They can make suggestions, but they can certainly test it. Open standards, on the other hand, what you're trying to say is, okay, we're going to open this up in a restricted manner. Yeah, what we're going to do is say, I've got some kind of system and the bits that you can add into it. So it still helps that innovation a little, right? So APIs help you to say, okay, this is how you can interact with my sort of black box. You keep that commercially secret, that black box, but you've got ways to interface. So in terms of identity systems, what we've actually got is we have got an open source project, right? And the open source project that we're working with, as you mentioned, is called MOSIP. It's important to also recognize that MOSIP is modular open source identity, right? And the thing about the modular is it helps overcome one of the challenges that we've seen in the identity space, and that is around vendor lock-in. So there are some very good companies, a small number of them, that have been selling identity systems to governments. And because of the nature that governments can change, they tend to be short-term. Particularly if there is a democracy, there'll be some voting kind of system. What will happen is an identity system might be purchased and started to be implemented, but its ideals change before it's fully implemented. Well, if you have a very expensive infrastructure project like an identity system, and then you want to change halfway through, that becomes very difficult. Or if you want to, change the purpose of it, so you get what's called vendor lock-in. Yeah, so you end up with that government, even though it was a previous government who may have put the initial contract, being tied to a specific vendor. So having a modular system allows you to get out of that kind of problem, because you can just plug in new bits rather than having to buy a whole new one.
So just to let me just summarize that for our listeners' benefit. I think so. What you're saying there is that a lot of national governments who have implemented these digital identity systems, they'll go to a company that makes software to do that, and that because those companies have their own proprietary solution, then if a subsequent government wants to add bits on or change things because they have different values or for some other reason, then they're stuck with that company or whoever the vendor happens to be.
Yeah, because that's the investment, right? So it has to integrate with what you've bought. And that means that there is a lack of competition. Yeah, because you know that you have to work with that company. And if there is a lack of competition, that means that you can effectively charge more, right?
Right.
So you end up locked in, and I'm not saying that companies will do that necessarily, but it's certainly possible.
The incentives aren't great, yeah.
Exactly, and that's a challenge. So what you've got is the modular nature of MOSIP challenges that. The openness means that it can be improved. But credit to the identity providers. There is now an Open Standards Identity Alliance, which has created some standards to say, okay, here are some APIs, here are some standards, and actually you can plug in. It overcomes some of the vendor lock-in. They keep their proprietary methods, but they allow some interfacing. And in an ideal world, that would interface also with MOSIP, so open as well as closed. Of course, having that kind of system, you have to recognize that how open is open, right? So I can create some standards, but if that main body, there may be bits that I just don't release APIs for, and you can't take in and change out. So there's still a challenge around how open and open standards approaches, but it's on the right journey.
Maybe just highlight a bit there. So we talked about the MOSIP project, which is an open source software project that, as you said, because it's open, because people can see the code, that, any bugs or any flaws in the system can be, shown by outsiders before it goes into deployment, during the development process. When you mentioned the other approach, which was these open standards, could you say a little bit about what we mean by standards in this context?
Yeah, so of course there is a big international standards community, and there's some formal bodies like the ISO, like BSI in the UK, and they are bodies that will define, the the approaches that one should take to developing something, and it could be systems, it could be how one builds houses or manufacturers windows. So there's various standards that can be composed, and thereby bodies that all feed into this ISO. For a lot of stuff around the internet, there's the Internet Engineering Task Force. They have standards for communicating. So you've got like gateway protocols and other kinds of protocols, and they're developed by experts. But again, they're other people. Yeah, and that's what's.
I think the example that comes to mind for me of like a tangible example is things like connector cables. You know, how everyone uses USB, for instance, because that's obviously a standard that some body such as the
It's the
IEEE has come up with.
Came up with that. Yeah.
Oh, okay, right.
Yeah. So that's it. So what it means is you've got that standard, for example, for USB, and it means that you don't just have to use that one company that created the USB standard, but anyone else can, and you can see there how it increases innovation and competition, right? And that standard is open so that the community can engage. And I think that's an important thing about that community involvement. I mentioned BSI and ISO. They make sure that that's mandated. If you create, if I was to decide I'm going to have some open standards, how much of the community do I involve? I could just say, here's a standard. Here's how you interface with my stuff, but actually not go into great detail. So there's a challenge there about how much the community participates in the development of a standard.
Yeah, so I guess to take an example which is the opposite of that, having either no standard whatsoever or having your own standard would be like Apple coming along being like, no, the new iPhone's going to use our special cable.
Exactly. I was about to say that. You had a headphone jack and now not.
Yeah, indeed.
Yeah. I'm not an iPhone user, so sucks for you guys if you are.
a little bit aggressive towards our Apple listeners.
but people will argue for different things, and it just depends what that organisation wants to do, and that's what is when you've got a sort of environment where it can be decided by an individual organization how they want to approach it. You need the governance. So we've got competitions and markets kind of thing. For example, we've got regulators that can decide that things aren't in the public interest. So some of the big companies like Apple and so Apple will have had the problems around Lightning, as you'll have heard. In Europe and other places, but also we see a lot of discussion about regulation for Facebook and Google and others as well.
I want to highlight something that you said very early on your answer, because we were talking about openness and security, and usually people, maybe most of our listeners or some of our listeners even thought that when we say open, it seems like it's going to be proportional to a less security, but it's actually the opposite, right? Like the more open it is, the more people can test and try to crash your system before it actually becomes before it actually has the relevant information.
So what do you mean exactly? Sorry, I'm not quite following you with the question there. It sounded like
sorry. So yes, I was just highlighting something because it was my next question, but because you already went through it, I just decided to highlight.
Thank you. Sorry, I thought you wanted me to respond because it was a question. I thought I didn't get it. All right, so that's good.
Because you already said what you wanted.
Well, I think the point that we were sort of going to ask you about was that you think open source software has security advantages, and it's not a trade-off between open and security, but rather
sorry. Now that you put it that way, I can elaborate a little. So my apologies, B. but what I'd like to elaborate on is what one can't say because something's open standard, it's definitely secure. And one cannot say because it's closed that it's insecure, and vice versa, right? So this is really important, and it's something that people think about, right? So there is a misconception that open source is insecure, right? And there are people in governments and others in the identity space that think MOSIP cannot be secure because it's open source, because it's all there for everybody to see. Well, of course, for the
Right.
reasons, as you just said, Ed, and I've said before, actually you get lots of people to challenge it, and you can find out what the weaknesses are, yeah? But that doesn't mean that it's secure, right? That means that you find out what the insecurities are, assuming that there's enough of a community to challenge it, right? Because if there's no one there to challenge it, then you don't even find out what the vulnerabilities are. But if you find them out, you then still need to fix them. And that can either be that MOSIP in this case, or it could be a community that tries to help patch it. Yeah? So it's no guarantee that it's secure, but it can help you be secure. Right. And conversely, in proprietary software, what happens is they will, if the code is not released, and this is the challenge, they can only go to their own closed community to find out what the security weaknesses are, the vulnerabilities. And that is not so good, right? Because people are from the same mentality, exactly, often the same engineering group. You know, people talk about marking your own homework. So it is often better to get a wider engagement. So that's why you've got to make sure there's enough testing, and that can be a problem. But once a flaw has been found in commercial software, they've got commercial reasons to try and address that. They may choose not to. They may choose never to disclose that there was a problem, but regulation will force them really to disclose. So it's a little bit more complicated than the simple open source is more secure or less secure than commercial, I'm afraid.
Absolutely. I think it's a really interesting topic, and I'll ask you in a moment a bit about what the Turing is doing in response to that. I think, my perspective on MOSIP is that it's a really interesting project because, of course, all digital identity systems will have been developed by governments, or, as you mentioned previously, they've contracted a private company to use their proprietary system before. Whereas what we're seeing here is something that, at least in theory, is being openly developed, so that all of these ways that we talked about that these bad actors can influence the system, whether that's authoritarian governments or people trying to pass themselves off as someone who they're not, all of the potential flaws that could allow for that. If the open source community developing the project becomes large enough, and has a diverse set of people highlighting these sorts of things, then hopefully, we should get a system that has all of those things in mind before it gets deployed. And I know that the project is going to be working with some countries like the Philippines and Ethiopia, potentially, in setting up their national ID systems. So it's going to be really interesting to see what happens there. But Carsten, tell us a bit more about the work we're doing at the Alan Turing Institute in evaluating trustworthiness, privacy and security of these digital ID systems, and how that relates to these open source ID projects.
Sure, I will do. Just to finish off, you had a lovely summary there of the open source, and there was just one thing that I really wanted to pick up on. Security researchers often find breaches in commercial products, right? One thing that's for definite, they would have found those weaknesses easier if they were open source. That's for sure, right? Because they've had to try and break it. You're doing some reverse engineering or something. So that's just one thing to note. And what's great about this project that we're doing at the Turing is we will be working with the whole community. So we'll be, creating new knowledge, but opening that up so that we get, just like we do as academics, getting the peer review, getting people to prod it. And that, I think, is fundamentally important, where the fantastic work that goes on in industry, really advances society and science. But the academic base tends to have this thing where we challenge each other. So if there's anything we later find is wrong, we can fix that problem because it's all really clear. It's got these clear building blocks, and we can find out where something was perhaps erroneous. So building upon that, one thing we want to do at the Turing around national identity systems is to make sure that we engage the community. So what we are going to do is we're already working with some of the key organizations like the World Bank, like ID for Africa, like ID 2020, and the whole academic community, starting with, of course, the Turing network that we've got, but we'll be encouraging discussions with organizations around the world to try and create something that really delivers trustworthy national identity systems. And trustworthy is a word that's used a lot, right? So, oh yeah, it's trustworthy. And I say, well, what do you mean? So we have a definition. In no way do I say this is the only definition, and in no way do I say it necessarily covers absolutely everything, because there's some semantics involved. But what we think it does is gives some simple way to understand what we should have in a trustworthy system. So the first thing is that there should be security embedded, right? So by that, typically, even with security, some people will talk about, well, security is confidentiality, integrity, and availability. Other people will say, oh, well, that's not enough. You need utility and possession. They will talk about Don Parker created this hexad of characteristics that needed. Some people have got even more, right? But we say, look, essentially, confidentiality, integrity, and availability are the fundamentals, and others
so
can
that's,
be.
That's a triad rather than a hexad, I guess.
Indeed, a triad. It's called the security triad, or the CIA triad. So for trustworthiness, we need security.
Oh, that's a cool acronym. Yeah.
Yeah.
Very memorable. Yeah.
As well as security, we need privacy. And the way we define privacy, and you can define it lots of different ways, and, I've got papers and grants around this, but we say that the privacy should apply to communication, so that there's private communications, and that's confidentiality effectively, right? But also in the computation and in the sharing of information. And this is where the privacy enhancing technologies notion comes from. So this is taking privacy into what we understand very much in an academic sense of privacy. Researchers understand these kind of things about privacy and communication, computation and sharing. But in terms of the identity world, if I was to ask people, because I did when I was over in Johannesburg last year at the ID for Africa conference, people said, oh, we are doing privacy by design. I said, fantastic. So how do you do that? And they said, well, we would use 256-bit encryption. I said, what, and that's it? They said, yeah. But of course, if you look at the Turing, there's some great work on, for example, just give one, differential privacy, which can give releases of information about a system and how it's used with privacy guarantees. So mathematically guaranteed privacy, which will protect people. And that's why we think privacy is much more in a trustworthy system. So it should be secure, it should be privacy, it should be consideration.
I don't know. I mean, I don't know much about security technologies. You mentioned this 256 thing. What is that? Some sort of like really basic technology then?
Oh, sorry. Yes.
I was going to ask the same thing. Yeah.
I'm so sorry. When you have any communication that you want to secure, so if I want to send you something that's encrypted, and I won't go into whether it's symmetric or asymmetric, but basically the information I send you is very often encrypted, so it's unintelligible to anyone who intercepts it, right?
Yeah.
And what you do is you think of what I do is I send you that information and I lock it with a key. I encrypt it with a key. And when it's not true absolutely, but generally the longer the key, the harder it is to decrypt. I say generally because anyone who knows a fair bit about security will go, hang on, there's weaknesses in protocols. It doesn't matter what your key length is, and that's absolutely true. So I don't want to go into that. But what I'm trying to say what they were trying to say is a certain type of, let's say, elliptic curve cryptography with 256-bit is pretty hard to break, and that's why they would say it's confidential. Yeah.
Okay. But
so that's what they talk about.
In the digital ID context, you were like, okay, but we need more than this.
Yeah, because it's not just about encrypting the data so that somebody who intercepts it can't see it. I don't know if you or your listeners will recall a number of different privacy breaches that have happened with releases of data. One of the most famous is the Netflix competition. Yeah.
No, I'm not familiar with that, actually. Yeah, go on.
Right. Okay. So it's really nice. So Netflix had a competition. It released lots of data. It was all anonymized. Yeah. Anonymized really almost doesn't exist, right? Because you can de-anonymize or re-identify, right?
Right.
So they released all this anonymized data.
This is information of what people have watched, but
exactly,
instead of a user's name, it would just be a number or something.
It would be a number, and it might say whether they're male or female, or what age, or their age or postcode. It have some things, right?
Yeah.
This kind of breach was well known back in the 90s when LaTanya Sweeney, looked at I think it's Wisconsin, where the government had released some data. And it basically said, oh, this person's got this illness and that. And it was all anonymized. But she just looked up another people's zip code data, the electoral roll, and said, oh, okay, so there's only one 45-year-old male on that certain street, and it happens to be the mayor. So she could work out what the mayor's ailment was, right?
Right. Yeah.
Those kind of approaches about taking different data sets or what we can do in the Netflix data. What happened is you had a number and it said, oh, they like these kind of films. Yeah. And it's got some information about them. But what somebody did is said, oh, I know another data set where people actually put their name in and say what films they watch. And that's the IMDb database.
Right.
So that's a database where, maybe you, Ed, you reviewed some films. So maybe, think of the last 10 films you watch. Yeah. Well, actually, you've written that in the IMDb database, yeah, and you've put your name next to it because, they're good films like John Wick or something like that, macho-type films, so you're not bothered about that. There wasn't, My Little Pony or Mulan or something like that you might be a bit more embarrassed about, let's say.
Right,
but you've put those reviews on. But your Netflix data has got those films on it.
Everything I've watched.
But it's also got other things. And what happened is people maybe watched same-sex stories, relationship stories. Do you see what I mean? So people were making inferences based about an individual person that they may have certain likes or dislikes. So that's the real challenge in data release. Yeah. So there are privacy enhancing technologies that say it's not just about protecting the data. If you release data, and this is important for the point that B mentioned before, right? A government might want to infer something about your religion, right? So there are certain religions that might have fasting at certain times. Yeah. So I might be able to use that. Oh, isn't it funny? This person never collected that aid, that food at these times. And I may be able to infer with some decent probability that somebody is from a certain religion. That was never provided information, but it can be derived from the data.
So
I bet all our listeners right now are thinking about all the binge watching that happened during the quarantine and thinking, what does my Netflix history say about me right now?
yeah, indeed.
Well, it raises a really interesting, more general point about what people can work out about you by linking data sets. And I guess, what you're saying is that there are some of what you call privacy enhancing technologies that can, limit these sorts of things from happening. But what are how do those kinds of dangers play into digital identity systems? Is this a case of just not wanting two different government departments to link your health data with your welfare data, or is it go deeper?
Well, that is a threat, isn't it? That's a threat. And when we do privacy threat modeling, or any kind of privacy analysis, we'll say, is this entity, this actor, are they honest? Are they semi-honest? So honest but curious. So they're not going to lie, but they're going to try and find out things. And we talk about, do they collude? Yeah. And that aspect of collusion is worrying, because, you know, it could happen that two departments or two. We've heard already about anti-competition kind of cases where there's collusion between companies. We've also got that a little bit where it's hidden, where there is a data set, and you'll have heard stories. I'm not saying whether it's right or wrong, but you'll have heard stories about Facebook and WhatsApp using data in certain ways that isn't what was thought to be or wasn't supposed to be ethical.
Right.
I can't say whether that is. It wasn't ethical or wasn't, but I'm saying there are stories about that, and what it does is it raises the possibility, not whether they did it or not. And this is the question, right? What is the possibility? Where we're in good places for governance, like the UK, like the developed world, that's one thing. But when you're in underdeveloped countries, yeah, they just don't have a stronger regulation. They may not have a strong government. So that becomes increasingly important.
And I guess, just having the technical competence to, you know, implement any safeguards against these kinds of threats of, compromising people's ID in certain ways is limited if you're a developing country.
Indeed, and that developing country, Ed, if I may, really brings us into this aspect of trustworthiness that we said, which is we also need to make sure that it's ethical. So we have this sort of catch-all called ethics. So I'll just go through them all for you very briefly. They are security, privacy, ethics, resilience, robustness, and reliability.
And these are all things that you're going to analyse digital ID systems on.
These are the 6 sort of facets that we talk about for trustworthiness. Yeah. And in that ethics, one thing that we've touched on is, you know, is it fair? Yeah. If there's any AI involved, is that AI fair, or does it disproportionately affect someone? Because you've got this identity system and it links to an individual person. Yeah. But ultimately you're going to use that for some kind of purpose, right? And that might be to work out where do you best deliver aid, for example, or what you do with money. So what we really need to do is, when there's some decision making based around the identity, it should be transparent. Yeah, I should know if there is a digital identity. When is my identity being checked? Yeah, I need to have that. There needs to be some transparency and some work that some of us at the Turing did on this project. And I think on one of your previous podcasts, you've had David Butler and Chris Hicks speak. The work we did on Secure ABC and some of the other things, we're talking about how do you know. What's the threat of somebody using an identity or checking something? We've got to make sure that transparency is there. We've got to make sure that it's fair and that it's explainable to people why they may be denied or something. You know, because we said before, your identity might give you access to some aid or not. You need to know why that is, in a sense, because so that you can challenge it.
So you think openness means that? Yeah, well, so you can challenge it. So you know, as a citizen or a user of this ID system, at least in theory, you can know why a decision was made, just as opposed to that it was made.
Yes, it's a really good point that I don't think has been picked up enough, actually. If you've got an open system, then not so much about an individual citizen, but there are groups that can protect you, that can go in and say, hey, look, this is doing something that appears to be unfair.
Right. That's interesting, because my next point was going to be, well, hang on a second. Most people aren't coders, so we can't just go and look at the code and be like, oh, this is doing something nasty. But I suppose that at least there are groups of people who, you know, then might collaborate with lawyers to highlight these things.
Indeed, and when you talk about that, it's interesting because. There was a recent case about live facial recognition, some trials that have been in London, some implementation of that. And Ed Bridges from Wales challenged it because it's used in South Wales quite a bit. And actually what he got is Liberty took on his case and helped him. You know, so he's not a lawyer, but he got legal support and challenged and appeals a decision. So there are people in consumer groups. So which is somebody who will get some experts and will look at things. So the more open things are, the more that people can act on your behalf, and it's not necessarily down to an individual. And academics will always try and do that, right? We're public servants.
Awesome. That's a very not that I'm saying I would have a negative view of academics, but that's a very good positive view of academics that I think we should all put forward, definitely.
I think that's. I was also thinking that another concern that people would have is because we're trying to, as we've talked before, we're trying to avoid more and more discrimination in our society. But this, if you could link data sets, it would be such an easy way to, as you said, you can figure out or you can make an educated guess about someone's religion, about someone's gender, about someone's political views, and this could always influence and discriminate, for example, candidates for a position, if you think about it, even if the curriculums have been anonymized.
Yeah, without a doubt. And that's why there are a number of different privacy enhancing techniques. I've mentioned some of the techniques that support some of the things I mentioned are differential privacy or k-anonymity and all the subsequent improvements that happened after that. One thing about differential privacy that's interesting is it's about a data set. So you release information about a data set. And what happens is if you are in that data set, B, if I have a data set and it's got you in it or you not in it, anybody who examines the statistics from that data set, the information that's released, cannot tell if you were in that data set or not in that data set. That is a guarantee of differential privacy. Yeah. And that stops some attacks. Yeah. Because you're just releasing it in differential privacy. You don't release the data, you release statistical data. Yeah. So I wouldn't release a whole set of people's salaries, but rather I might say, here is the average salary. Yeah. And that average salary is released in such a way. So you add noise to the data, right? So that it's released in such a way that actually it's good enough to work out for anyone who needs to know what's the average salary, maybe for, what one could do about health, for example, right? So you find out the health of people and you might use that as a decision how you distribute funds in a country. Yeah. Well, they need to know roughly, it's not down to an individual, every individual's, but they need to know roughly how much need is there in a certain county, for example, yeah, or a certain region. Mm-hmm. And what you do is you take the exact answer from everybody's need and you perturb it in some way. You either add some randomness in or you add some noise in, whereas the answer is still good enough for those decision makers, but it means that I can't tell whether B was in that data or not.
So what you're saying essentially is that there is this way of doing things so that governments can still release data that's useful either for themselves or for other people to analyze, that's data on the population, but which doesn't compromise the integrity of individuals' identity. Indeed,
yeah. And there are other techniques that I won't go into now, such as homomorphic encryption, some of your listeners may have heard of, where actually I can release encrypted data and there can be some basic operations done on that. Some people could add to it. I could send you some encrypted data which has got, it's got a list of all people's shoe size, yeah? You add your shoe size into that database, so it's got a running count. You then pass it to Ed, and he adds his. And what you effectively do is you encrypt your values to go into the database, and you can just add the two encrypted versions. And the sum of that is actually the same as the sum of the individual's data having been encrypted. So I can pass that around. It come back to me. So you don't get to see it, and all you're putting in is encrypted data. That's homomorphic encryption.
So you're able to do calculations on data without actually seeing the data.
Yes, that's exactly right. Yeah. So there's that, or the secure multi-party computation as well, and we'll certainly be looking at that, I think, where you derive some knowledge from a data set that two different entities have got a data set, and they want to find out some information. One way is to have a trusted third party. They both share the information with a third party, and then an answer comes back. But secure multi-party computation allows you to derive some knowledge from the data without actually sharing the data. So both parties learn some common thing. Inspired by the millionaires problem, where two people wanted to know who is the richest of these two millionaires. Easy ways, they tell a third party, and the third party just gives the answer. But secure multi-party computation allows a way where both parties, without sharing what their wealth is, can work out who's the wealthiest of the two.
Interesting. That sounds really useful for comparing salaries with your employees, perhaps.
Yeah, indeed.
Awesome. Carsten, thanks for coming on the podcast. And
thank you so much.
Yeah, I think these privacy enhancing technologies are really interesting, and it'll be interesting to see how the open initiatives like MOSIP and others in the digital identity system space pan out, and I'm looking forward to carrying on the research. Before we let you go, we've got one more bonus question, which I'll hand over to Bea for.
Yes. So when you consider things like, privacy and security and trustworthiness, which country that currently uses a digital ID system do you most admire, and which one do you least admire? This is a nice way of us asking you to just give us a little bit of dirt of your opinions.
Yeah. Well, I can say that I really admire a couple of examples, which are the way that Germany is doing its system, and Estonia, because it's so widespread, right? So Estonia's got a digital ID that's widespread, but the German one is really couched in a lot of principles about protecting individuals. There really is a strong sense of that in Germany. So I would say that Germany or Estonia are the ones that I think have done a great job. I'm afraid that the Sun's not going to be carrying a headline tomorrow, because I can't go in and say what is too critical, because I think, in essence, there's always a good reason for creating a digital identity, yeah? And I think most governments and others that want to push digital identity systems have essentially some good uses there. But I think there are things that they can be abused. So there are some worse instantiations. There are countries, and I don't need to name them, where human rights are not as well thought of. So if I wanted to say what is unfair, in a sense, without putting myself on the hook, I'd just say, think of those countries that have got poor human rights records, and if they have got a strong digital identity system, it's probably not designed to protect the individuals.
I like the political correctness.
Too much to lose, sorry, B. If you'd have asked me 20 years ago, 25 years ago, I might have given a different answer.
Yeah, I guess people can think in their minds which countries might be not democratic, but also technologically advanced enough. Then maybe
indeed
you've got your answer.
I think everyone is like shouting names in their minds, like, I know.
Yeah.
Okay. Thanks, Carsten.
No worries.
Before we let you go, where can people find your work? Do you have social media that people can follow, or a website?
They can follow me on Twitter @CMaple. Easy enough to remember. They can look. Some of the projects I work on are on the Turing website and some of the Warwick website, WMG. I'm part of WMG at the University of Warwick. But also, as well as this, I do other kinds of things like this. So probably if they search for my name, there'll be various things I did. Goodness me, I've done a Jeremy Kyle Investigates, the Kyle Files, you know. So I've done all sorts of stuff before. The project that we work on was mentioned in Wired today. So what is it? Friday the 4th of September, 2020. So yeah, they can find various things by going to a search engine of their choice and looking up my name. But C Maple on Twitter is one way as well.
Thank you.
Yeah, the Jeremy Kyle thing sounds interesting, but we won't go into that right now.
No, don't.
I was like, I have questions now, but okay.
All right, thanks, Carsten.
Okay, thanks so much, guys. Take care.
Thank you.
To learn more about the work going on at the Alan Turing Institute, visit our website at turing.ac.uk. To get in touch with the podcast team if you have any questions or suggestions, email us at podcast@turing.ac.uk.
Music for this episode was provided by Jamin Sun. You can listen to his latest releases at jaminsun.bandcamp.com.
The Turing Podcast is hosted by Ed Cowstry, Tara Callum, Ben Walden, Effie Dennis, and produced by Dan Whitfield for the Alan Turing Institute.